Okay, please confirm if my screen is visible. Are we good to go? Okay, Ratna, thank you for the confirmation. Okay, guys. So we are going to complete the collection framework, and so our discussion is going to be on top of TreeMap. Okay, so we have completed map interface, and we have also completed about hash map, linked hash map, and identity hash map. So this will be discussed at the last. The sorted map is also completed. Navigable map is also completed. So today we will discuss about the tree map. Tree map is very easy, as we have already discussed about the tree set. The same concept will be applied for tree map also. Okay, so let us try to understand how exactly this tree map works internally. Okay, so this is the tree map. And if I ever had to do the recap, the previous sessions we have discussed about navigable map, right? And we have seen some methods on top of navigable map. So let's focus on tree map directly. Let us jump to the tree map directly. Okay. So first of all, it was introduced by looking at this picture. We have a conclusion, because tree map implements navigable interface, a navigable map extends sorted map, and sorted map extends map interface. So the conclusion is, I can directly write it like it is an implementation class for what? For navigable map, sorted map, and map interfaces. Right, first point. Second point, when it was actually introduced, it was introduced in JDK 1.2 version. It was actually introduced in JDK 1.2 version. Okay, so when something is getting introduced after JDK 1.0 version, okay, when something is not introduced in JDK 1.0 version, 1.0 version, when something is not introduced in 1.0 version or the first version, so we always call them as what? The non-legacy classes. These are non-legacy class, right? And the fourth point, right, I can, since this tree map, when you look at the diagram, tree map is implementing navigable map, and internally this navigable map is extending to sorted map and the map. So all the points that is applicable for sorted map as well as navigable map could be applied for tree map also, right? What are the points that we have for navigable map? Exactly the same points are going to be applied for the tree map also, because it is tree map is implementing navigable map interface, right? So all the properties could be acquired for tree map as well. So let us copy all these properties. Yes, all the 10 properties. So it is going to store the data in the form of key value pair. Okay, fourth one. Okay, and please be informed that keys are unique and the values can be duplicated. Okay, and instead of navigable map, so we need to change this to what? Tree map. This is the only one change that we require to do for everything. If you get a question, for navigable map, okay, every points are, I mean, most of the common points are like, taken for all this tree map, navigable map, as well as the sorted map. There are about 7 common points. Okay, you do not want to memorize everything. Remember one topic, so it will be applied for all the remaining topics, especially for the maps. Right, so tree map, and here I need to change this to tree map. So we have got 10 points. Okay, apart from this, since we also need to talk about the internal data structure of tree map. Okay. Tree map internal data structure is, it is going to use a tree called red flag tree. We will understand what is red flag tree. Okay, first we will complete the theory. Okay, we will understand the internal working of TreeMap in a short period of time. Okay, and the 12th point. So it is non-synchronized in nature. Next. Okay, so for the non-synchronization, so whenever a Java concept is not introduced in JDK 1.0 version, okay, it is going to be what? It is always going to be 99%. It is going to be non-synchronized in nature. Okay, I can copy all these points. When something is non-synchronized, you can keep all these points as it is. It follows parallel execution. It is not thread safe. It is high in performance. There will be no data consistency. So the 13th point, 14th, 15th, and 16th. These are the ideal points about TreeMap. Okay, let us understand about constructors inside TreeMap. Constructors in TreeMap. Okay, firstly, we have a constructor like public TreeMap, an empty constructor, a default constructor. Let us understand what is this constructor is going to be, right, in the Eclipse editor. The TreeMap. So I am taking the since TreeMap is going to store values in the form of a key value pair. So the first data is going to be an integer, just an assumption. Okay, and the second data is going to be of string type. Okay, this is representing the key, this is representing the value. Okay, you can take any variable name. So let us take that the variable name is students equal to new TreeMap. So I can create an object directly. Okay, so this is representing, okay, this is representing a constructor which is empty, or default constructor, empty constructor. See, so when you create an empty constructor by using the TreeMap, and if you try to print system.out.println students, okay, and since you did not add any data, output is going to be empty, right? Empty, right? And you also have an option to pass some other reference variables here of map type or sorted map type. What do I mean exactly? For example, if I take if I am creating an object by using the map reference variable, by using the reference variable of map type, right? So the variable name is new TreeMap. Okay, let me add 3 elements. The student number 1. Let me just take a /1. Okay, let me quickly add 2 more students. Student number 2, Jyoti. Okay, I want to add another student. Student number 3. Okay, let us keep it as Ratna. Okay, let us shuffle this. Okay, 3, 1, 2. Okay, here I am using a map, and here I am using a TreeMap. Okay, what I am trying to do is, so instead of TreeMap, let me use it as map here. Focus here. Instead of TreeMap, I am using map. Okay, so this variable is representing, it is collecting data by using the concept of map, right? This is collecting data. The students, the reference variable is going to collect data of what type? Of internal data structure of TreeMap type. Okay, so I can pass this reference variable to the constructor of TreeMap directly, right? If I print the reference variables, okay, see, the first line, The first system.out.println statement is giving this as an output. Okay, the second system.out.println statement is giving this as an output. Right? You can ideally pass the reference variable of another type to the TreeMap constructor. Okay, so for example, this may not look good. Let me take string type. Both of the types, let us keep it as string type. Okay, here also I want to take it as string type. Here also I want to take it as string type. So we know already the hash map is going to store elements in the form of key value pair, and it does not follow insertion order, and it does not follow what? Sorted order. So I can give the key value pair like Ratna is from Chennai. Chennai belongs to Ratna. Bangalore belongs to Ashwant. For an example, I am taking like this. Hyderabad belongs to Jyoti. Right? So literally we know that this hash map is not going to follow the insertion order. Right? It is also not going to follow the sorting order. Internally there is a data structure, and it is going to use the hashing mechanism to store the respective keys. Right? Let me remove this. So try to print the reference variable of hash map. So I get output not in the actual order, in a different order. See, I have added Chennai, Ratna, Bangalore, Shashwant, and Hyderabad, Jyoti. But look at the order. Order is in a what? In a random order. We are getting the output in the random order because internally it is following what? Hashing mechanism. Okay. What if I want to get this? Okay, without changing anything. What if I want to get this in the sorted order? How I can achieve this? Just by passing this reference variable to the TreeMap, and if I print the reference variable of TreeMap, okay, what I have just done, I am just passing the reference variable of hash map, reference variable of map type, which is hash map, to the constructor of TreeMap. Right? If I print this now, the data that was unsorted before, now it is coming as a sorted one. Are you able to follow this? Okay, here you have an option. So TreeMap is going to help you with the constructor, that in this constructor you can pass either sorted map or either hash map, any kind of map type. Right? It is going to give you the output in the sorted order. Right? So this is the second constructor that we are discussing. The constructor 2 is public TreeMap, and you are allowed to pass the constructor of what? Map type. Okay, and you are also allowed to pass the constructor of what? Sorted map type. Sorted map type, etc. The output will always be in the form of what order? Sorted order. You see, the output is sorted. The keys are sorted. Don't get any confused. The keys are always sorted. Bangalore followed by Chennai followed by Hyderabad. Previously it was not sorted because it was using an hash map. So once you pass this reference variable, the constructor of TreeMap, the output is coming in the form of sorted order. Okay, this is the takeaway. These are the constructors that you have with the TreeMap. Are you getting this? Now for the methods. For the methods, all the methods that you have for navigable map and all the methods that you have for sorted map can be used for the TreeMap, because TreeMap is implementing both interfaces. So all these methods are applicable. So I can copy and paste all these methods. Okay, so let us keep it as 6 and 7, 8 and 9, 10, 11, 12. That you can get first key, last key, and you can get head map method, tail map method. We have different kinds of method which has been discussed already. So I don't think any explanation is required for this. Okay, now let us try to understand the internal working of TreeMap. Okay, focus here. This is going to give you some insights. Okay, after completing this, we will understand where exactly this, where are the used cases of this TreeMap. Okay, so I want to take an example, guys, a real-time example. So not the real-time example, the real-time analogy. Okay, for example, let me go to the plain screen. Okay, so whenever you are visiting a college, whenever you want to take admissions in a college, okay, let us take the name of the college as ABC College, right? So they generate the registration number. Especially they usually college they don't consider the names. Instead of names, they always consider the registration number because they feel that registration numbers are always unique, no matter how the name is, because one person, same name can be assigned to many persons. So they want to make sure that every identity is unique. So they generate registration numbers. Generate what? Registration numbers, right? So if a person is going for an admission, okay, and what he is going to do, for example, if Ratna is visiting an office, the ABC College office for an admission, right, and they give him a registration number like 100, some kind of number. Let us say that some kind of number. Let's say that Shashwant is visiting, yeah, and Shashwant gets 90, a kind of number. Let us say that Vijaykanth is visiting, and Vijaykanth is allotted with 120, and let us say that Jyoti is visiting, and Jyoti gets the registration number as 80, and Sagar is visiting. Sagar gets registration number as 95, and Venkatesh is visiting, and he gets registration number as 105. Last person, Jyoti N is visiting, another Jyoti, she gets registration number as 125. Okay, so these are the randomly generated registration number for these 7 students. Totally we have 7 students. Okay, what they usually do, so based upon the registration number, they want to do the sorting. So they just want to consider the registration number. Okay, they can either do two things. They can either sort the names or they can sort the registration numbers. But here the takeaway is registration numbers are always unique. So it's better to sort the registration number. So if you want to sort the registration number, the key should always be the registration number. The value should be the names. The key value pair. You are making what? You are making key value pair. Key should always the registration number and value should be what? The names. Why the value should be names? Because names can be duplicated. There are 2 Jyotis here. Okay. So fortunately, these 2 Jyotis, the Jyoti N is different because we are able to identify the difference between these 2 names. Sometimes there are chances that one name can be assigned to many persons. In that case, there will be a confusion. So the key should be unique. You need to consider the key property as a unique one. Okay, and if you look at the key property, so if this is how the order, if this is how the students got the admission in this order. Okay, so the registration number has got generated randomly. If you want to sort the key, if you want to consider the key as the unique thing, you need to sort the keys. Okay, you need to sort the keys accordingly in such a way that the registration numbers are sorted and the names will follow that. The names are going to follow that. Right? If this is a situation, you will use what? You will use a concept in Java which is called as what? TreeMap. You're going to use the TreeMap. Okay, let us use the TreeMap and let us take the same example. Okay, let me remove all this. Okay, my key should be what? My key should be integer because integer is going to be unique so that I can sort the integer. I can sort my keys accordingly to get the sorted output. Integer. Right, let me remove this. Okay, let us do the same thing. Okay, let us do the same thing which we have just done now. Students dot put, okay, and 100 for Ratna. Okay, and let me copy paste students dot put. Let me copy paste. So we have 7 students and we have 7 registration numbers. Shashwant, Vijay Jyoti Sagar, Vijay Jyoti, and we have Sagar, and we have Venkatesh, and we have what? Jyoti. Okay, and their registration numbers are like 90, 120, 80, 90, 120, and 80. What is 95? 105, 125. 95, 105, 125. Okay, when I just try to print the reference variable of this TreeMap, so you know that the output is going to be in the form of sorted order. The key will be sorted, not the values. So the values are going to follow the respective keys. So the key is sorted, and the respective values are going to follow the keys. Right? So we are getting an output like this. What are the things that is happening behind the scenes? Okay, what they say is internally, so internal working of internally it is using the red black tree. Forget about what is red black tree. Just remember this word, red black. I will keep this very simple. So here, let us take these lines, these pieces of code to visualize the internal working. We forget about the red black tree. Let us assume that it is a tree, it is a binary tree, whatever it is. Okay, now you see elements are getting added one by one. Okay, firstly a tree will be created. So a tree cannot be created automatically. We have discussed these things already in the tree set. We call it as what? A node, a root tree, or else we call it as what? A node. Node is called as, it is like a root. A tree will not created automatically. First root will be created, then followed by the branches, followed by the leaves. This is how the tree grows naturally. But in Java, if you want to visualize the binary tree, which means firstly there should be a root node. We call this, the first node is called as what? The root node. This is called as what? Root node. Right? And what are we doing? We are adding the key 100. Okay, and what is the value? Value is what? Okay, the first element that you are adding will definitely occupy the root node, no matter what. First element that you are adding will definitely occupy the root node. Okay, since this is a root node, it is ready to create, maximum it can create 2 branches. Binary tree means 2 branches, only 2 branches it can create maximum. It is ready to create only 2 branches, not the 3 branches. This is not possible. This is never possible. This is a binary tree. At most it can create 2 branches. Okay, now good. Second thing, okay, you are adding the key as 90 and the value as Shashwat. Right? So what you are doing here? You are adding the key as 90 and the value as Shashwat. This is what you want to do. Right? So this key value pair, okay, key will be compared. Key will try to occupy the root node, but this root node is already occupied by the person Ratna, by the key 100. Okay, now the key 90, this key 90 will be compared with this 100. Okay, if 90 is lesser than 100, it will take the left side, it will take the left path. If 90 is greater than 100, it will take the right path. For understanding, 90 is greater than 100, it is going to take the left path. If it is lesser than 100, it is going to get left path. If it is greater than 100, it is going to take right path. Okay, we have discussed these things in the tree set, guys. The tree set classes, we have discussed these things. Internally, it is going to use the compare to method. What is a method? Compare to method. Compare to method. If you are not recollecting, just go back to the tree set class, you will understand. Compare to method. This compare to method is going to return either minus or minus value, or the plus value, or the 0. Okay, so each and every value is going to use the compare to method to check whether it is lesser or greater or equal. Okay, if it is lesser, it is going to take this path and it will get occupied here. Shashwant is going to get this question. So this left hand side path is to store the less values. If the value is lesser than the root node, it is going to choose this path. The value is greater than the root node, it is going to choose what? Right path. Okay, second thing is also done. Now the third input that we are trying to add is the key 120 and the value is what? Vijay. Right? What is the key? 120. Okay, and the value is what? Vijay. Okay, so this value 120 will try to go from the root node, but in the root node already the value 100 is there, key 100 is there. Okay, now this 120 will get compared with this 100 and 120 will get compared to each other. Okay, this 120 is greater than 100, it is greater than 100. If it is greater, so this is greater, this is lesser, means left. If it is greater, this will consider this path, right path. So Vijay, the key 120 will be stored in this one. So again, for these two nodes, again for this sub node, 2 branches will be created, and for these 2 branches will be created, right? And you can add. So this is how it works internal. Okay, we have added totally 3 key value pairs. What is the 4th key value pair? 4th key value pair is key is 80 and the value is Jyoti. Key is 80, the value is Jyoti. Okay. It will start from the root node, right? So 80 is lesser than the key that is already there, 100. So when it is lesser, it will take the left path, right? And again, now it will try to occupy this particular node, but already 90, the key 90 and Shashwant is there. So again it is going to get compare itself with this particular key value, particular key. So obviously 80 is again lesser than 90, so left path, so it will settle here, right? Next data we have is 95 Sagar, isn't it? Right? Sagar. Okay, this key will be compared from, will start getting compared itself from the root node. So root node already value 100 is there, so lesser, 95 is obviously lesser, so this direction. Okay, now this 95 is greater than this 90. Okay, greater means right, so right hand side, this it will come this side, right? This is also done, and we have what, when 95 is done, we have 105, which is for Venkatesh. Okay. Right, the comparison will start from the root node. So 100 is lesser than 105, so 105 is greater, so right direction. Okay, and from here 105 is lesser than 120, so left direction. Lesser means left direction, greater means right direction. It is going to get settled exactly the same node, and when we are retrieving it, you are going to get the output in the sorted order. Okay, now the last, I mean not this one, the last, this is done. We have 125, which is generated for Jyoti. 125 Jyoti. Okay. This 125 will be started from the root node, greater, because since it is greater, it will take the right direction, right hand side. Again it is greater than 120, again right hand side, it will get settled. Okay, this is how it will get inserted in the red black tree. You just imagine this as a red black tree. You don't want to worry about what is red black tree. This is the internal data structure. Red black tree. This type of data structure is called as red black tree. And so this is how elements are stored. When you are trying to retrieve this, it is going to follow the in-order travels. Okay, in-order traversal means left, starting from left, going into root and getting the right. The direction is left, root, followed by what? Right. Left, root, right. Okay, so which is the extreme left element? Okay, from this tree, which is the extreme left element? Extreme left element is this is the extreme left element, right? So this data will be retrieved first. Left. This data will be, when you try to print the reference variable, so you are trying to print what? You are trying to print the reference variable of students. When you try to do so, it has to retrieve all the elements that is available in the tree. Firstly, Jyoti will be retrieved. Okay, so for this particular node, if it is left, and this should be root, right? And Shashwant will be retrieved. And if this is the root, obviously this must be right. Right, 95 Sagar will be retrieved. Right, after this you have done with this, right? So you make a big circle here. So this, okay, or you can make a square here. You have completed this. Okay, so all this spacious part which has 3 nodes is going to be what? The big left. Let me use a different color. You can consider this as a big left. For this big left, this is root. Okay, this will be retrieved. Okay, we have totally retrieved 4 elements. Just focus on the order how it is getting retrieved. When you focus on the keys are exactly getting required as per the sorted order or the ascending order. It's so, right? So Ratna is also retrieved. Okay, and this is going to be what? The big right. Okay, so this is going to be right, and within this right there is a left, there is a root, and there is a right. Within this right there is a left, there is a complete left, there is a root for this complete left, and there is a right for this boundary. So this left this key value pair will be retrieved. 105 Venkatesh, and we copy this instead of remove it. We are just doing the retrieval. Okay, and this will be retrieved. Just same like the as set, guys, nothing else. So preset, which we have discussed already, and this will be retrieved. This concept is called as what? The in order traversals. Okay, it will start traversing from the root node, followed by the it will start traversing from the leftmost node, followed by the root node, followed by the right node. Okay, this concept, okay, the way that the elements are getting inserted will be inside the red black tree. You do not have to worry about what is red black tree. If you are getting a question like what kind of data structure that the tree map is using inside, you can say that it is using red black tree data structure. How the elements are getting retrieved, it is following the in order traversal. In order traversal means taking the element or retrieving the element from left, root, right direction. Right? So this is the internal working of TreeMap. This is the reason why when you try to print the reference variable, all the elements are getting printed in the sorted order. Right? For example, if I try to add an element like null here, okay, so this null element, you cannot add null as a key. Why? Because if you add null as a key, it cannot be compared. You can add only comparable elements. So these are the numbers. You can compare numbers with numbers, no issues. But you cannot compare numbers with null because the internal data structure is designed in such a way that it is going to accept only the comparable objects. The moment you pass null, you cannot compare this null to differentiate which is larger and which is smaller. Of course, I mean, this is not even a number, and you cannot compare something that is not even a number with a number, right? That's why you get what? That's why you get the class cast exception. Sorry, null pointer exception. I mean, the class cast exception is a different thing. Null pointer exception when you add null. But when you add something like, so till here it is accepting integer, right? And in place of key, instead of integer, if you try to add something like Chennai, okay, so let me remove this generic type. Let me remove this generic type because you are trying to violate a rule. You're trying to violate a rule. What is that rule that you're trying to violate? Till the line number 24, you are adding the register number as keys. But in the line number 25, you are adding a string as a key. It's not a number. Till here it was a number for keys, but from here you started adding something like string. Okay, you will get what? The class cast exception. So this explains that you cannot add the heterogeneous keys or heterogeneous values. You cannot do this. So if you are choosing the numbers or integers as a key, everything must be integer. You cannot change that. You cannot change. You do so, you will get what? Cast exception. So ideally, I am trying to give justification for for this one. Why it allows only homogeneous element. If you are trying to add heterogeneous element, you get what? Class cast exception, right? And the tree map follows ordered orders with respect to tree, with respect to keys. By default, tree map does not follow insertion order with respect to keys. So all these points, I am giving justification for all these points. And you can, by default, tree map follows only comparable objects. We already seen what is a comparable object, right? So this is a simple internal working of tree map, and we have seen about the constructors. So I made this very simple because we have already discussed these things in the tree set. Don't forget this. There is a concept called tree set, which we have discussed this already in detail. If you want anything, you can refer that. Everything is same. Refer that video. Tree set. Refer that tree set video. Right? Now let us try to understand the use cases. Where exactly these tree maps are used? Use cases of tree map. So there will be a lot of requirement in the real time where, for example, so our just we have discussed about in a college. If you want to sort your names, sort your registration numbers, which is following the names, so they can use this tree map. So when you want to, like when you are using tree map, and if you want to search, or if you want to insert, or if you want to delete, all these operations can happen within big O of login time. Big O of login time means it is going to take the logarithmic time of big O of n, because the tree is red black tree. Right? For example, if you're trying to search for an element, like if you're trying to search for the key 125, maximum how many searches is going to take? Maximum, if you want to jump from here, how many jumps maximum you may take? The size is, if you have 7 elements, I cannot say that I will take maximum of 7 times. I can find Jyoti in 3 steps. This is considered first step, second step, and third step. even though if you have a length of element 7, if you have if you have keys, if you're adding 7 elements, 7 keys, it doesn't mean that I am going to take 7 steps to find Jyotian. Within 3 steps I can find with this TreeMap. So login, okay, this is called as we have discussed the same thing in the tree set also. If you want, you can refer that video once again. Okay, for the search, for the insert operation, for the delete operation, it takes algorithm time to from the TreeMap. Okay, I think that's it about this TreeMap. And if you want to sort the keys in the ascending order, and if you want to get the benefit of searching operation, insert operation, delete operation in the a short period of time, in the login period of time, you can use what? You can TreeMap, and you can just try to practice these methods on top of TreeMaps. First key, last key, head map, tail map. Everything is going to same, which has been discussed in the navigable map as well as in the sorted map. Okay, so let us conclude this session, and